Hello dear students, today we are going to now continue our lecture from the previous one. This is lecture number 16 of psycholinguistics, which is a continuation of what we were studying previously. What we're going to do is we're still going to continue studying about anaphors and their relation of how it relates in a sentence. Now, an important distinction in anaphors, if you see in lecture 15, we were studying about how anaphors are used. So this is a continuation of that. So an important distinction is also made between surface anaphors, which require an antecedent that is linguistically present, and deep or conceptual anaphors which do not, as in, now for example, you remember from the previous lecture what an anaphor is. So an important distinction, a difference that comes between a surface anaphor would be that it requires an antecedent that is linguistically present. So anaphor which do not would be that the car needs washing. Don't make promises, just do it. Now in E, in the sentence E, the listener or the reader has to interpret the anaphor, do it by reference to the entire meaning, representation, rather than to a specific entity held in focus within it. So don't make promises, just do it. We can't just do it, we can't understand do it from just that sentence. What we need to do is refer back. The car needs washing. Now that sentence has to be referred to also for the listener or the reader to understand the anaphor used in the next sentence of do it. So the car needs washing, don't make promises, just do it. That means that just do it means wash the car. You see, so it has to show that, represent that also, for the whole meaning to be clear. Now, children learning to read find anaphor resolution problematic, and the ability to resolve anaphors has been shown to be an important factor distinguishing skilled from less skilled readers. So children learning to read an anaphor, children who are learning just to find out what problematic anaphors are, and the ability to resolve the problematic anaphors would be shown as an important factor in distinguishing the skill from less skilled readers. So people who can't read clearly and the people who can. Now the distance between antecedent and anaphor is an important factor. Resolution appears to become more difficult as the memory load increases. So resolution would be more important also, or it would appear to be more important, even though the memory load is increasing. So however this effect is observed to some degree in all young readers, what especially marks out the less skilled reader seems to be a tendency to link anaphors to the nearest possible antecedent, rather than to a developing mental representation of the whole task. So what they do is, a younger reader wouldn't, let's say, try to understand what the whole text is, but they would immediately take the nearest possible antecedent and link it to the anaphor, trying to understand it, instead of trying to distinguish the whole text. So they may even make links to real world phenomena outside the text, assuming that now refers to the moment of reading, not that of writing. Now this is all assuming if it comes to the moment of reading, not in the matter of writing a language. So language acquisition researchers working in Chomskyan tradition have concerned themselves particularly with cataphora, sometimes termed backward anaphora, where a pronoun refers forward to an entity which has not yet been mentioned. So sometimes how we acquire a language, and researchers have worked on it in the Chomskyan tradition or Chomskyan view, and they have concerned themselves particularly with cataphora. Cataphora means that sometimes termed backward anaphoras, anaphoras that are termed backwards, where a pronoun refers forward, moving forward to an entity which has not been yet mentioned, something that hasn't been mentioned in the sentence before but moves on to mention that. So maybe that would help better if we would refer that. Now, at a surprisingly early age, children are capable of correctly attributing referent to the pronoun he in sentences such as while he was dancing, the Ninja Turtle ate pizza. So surprisingly, even though they're young, because that topic would interest them. So it would be maybe easy for them to understand a pronoun reference in a sentence if it's of their interest. So while he was dancing, the Ninja Turtle ate pizza. The Ninja Turtle being the subject, so we use the pronoun on the start. He was dancing. While he was dancing, the Ninja Turtle ate pizza. So it may be easier for a child to understand that. They can also distinguish this type of sentence from one such as he was dancing while the Ninja Turtle ate pizza. They can see the difference between it, where he does not refer to an entity within the sentence. So another area of research has been the processing of reflexive pronouns. At an early age, children are much more successful in interpreting a sentence containing a reflexive "Cinderella's sister points to herself" than a similar sentence containing an ordinary pronoun "Cinderella's sister points to her." So sometimes at an early age, they would be more easier for them, they would be successful at trying to understand or translating a sentence for their understanding. Cinderella's sister points to herself. That would be maybe more easier for them to understand than a sentence that is much more simpler and using an ordinary pronoun and much easier to understand. Cinderella's sister points to her. Maybe that would be difficult, they wouldn't understand who the sister is pointing to, but the first one, when they say herself, then that's maybe more easier for them to understand. Animal communication. Now, animal communication, the transmission of information between members of other species, including transmission by means other than sound. Now, when we talk about animal communication, that also is a form how the brain works in the process of communication. It's not all about just how the humans work. Like in previous lecture, I think in number 13 or 14, we discussed about animal communication. So you can refer back to those lectures and see what we were talking about. So animal communication would be the transmission of information between members of other species, including transmissions by means of others than sound. So they can, even the transmission of warning, instead of just making sounds, they can also communicate with each other. Now, like we said, that a prey to a predator and a predator to a prey, they also communicate. So it's not a must that it has to be the same species and they have to be transmitting the communication through sound. So studies of animal communication attempt to determine whether language can be said to be species specific or peculiar to the human race, which is peculiar to the human race. So either we can say that it is an attempt to determine that animal communication would be a language that can be only one species to another. Like only a dog can communicate with a dog, or a cat can communicate with a cat, or a bird can communicate with a bird. That would be peculiar to the human race. Now, examples are cited of systems of communication which resemble speech. For example, the call of vervet monkeys and the dancing of bees. Now that also is a major thing that also is a language in its own. You see, the calls of the vervet monkeys also is a language of its own way of communicating. And then the dancing of bees. The dancing of bees also represents how what they are trying to communicate to the fellow bees. So both involve displacement, the ability to refer to entities not immediately present. They're both referring to displacement, both are referring to the ability to refer to entities that are not immediately present. So a dancing of the bees can communicate not only to fellow bees, but also to humans. We can also understand that or differentiate what it means. So, but both are limited in the repertoire of signals involved. So both are still limited to what signals are involved in it. And it might be suggested that they are indexical. So the signal relating physically to the message rather than symbolic. So it's not all about that. It's that both are limited in the signals that are involved in it. And it might suggest that it's indexical. That means that the signal related physically to the message, indexical would mean that, rather than the symbolic meaning. So more interesting examples are the clicks used by dolphins to communicate information, and the songs of male whales, which change from year to year. So more interesting examples would be the clicking sounds that dolphins make to communicate. Many humans have distinguished those sounds also to distinguish the talk between what dolphins are meaning by when they are clicking, or the songs that every year they change in the male whales. So in an attempt to specify what characterizes language, so Hockett in 1963 proposed certain design features which are often quoted when determining to what extent any type of animal communication is speech-like. So Hockett in 1963 proposed that certain design features which are often quoted when determining that what extent does animal communication resemble speech. No type satisfies most of Hockett's criteria, so none of those really satisfies his criteria that animal communication would resemble or would be like speech-like. Now, a particular obstacle lies in the fact that most animals are not physically capable of producing the kind of vocalization which occurs in language. So most of the time we can say that a particular obstacle lies in the fact that sometimes the obstacle in understanding is that most of the times the animals are not physically capable of producing that kind of vocal language that humans use to produce a language, to make it occur, that things that occur in a language. Now this is not simply because their vocal apparatus is different, but because ability to vocalize depends critically on having air passages which are not given over entirely to reflex breathing movements. So most mammals have larynxes which are controlled by the brain's motor system, whereas humans have a much greater degree of voluntary control over the sounds produced in their larynx. So they can thus utter speech sounds while breathing out. Animals or mammals can't do that. Some of them would have larynxes which are controlled by their brain's motor system. Some of them would have that ability. But humans have the complete voluntary control over their larynx to produce sound. How we breathe in, how we breathe out. Like I've taught you in previous lectures, the way, the pattern of the airflow. Now that is not controlled with just our motor skills or our motor system. It's the voluntary control, that degree of control that humans have, that differentiates, and in that's how we can distinguish psycholinguistics, that the study of the brain processing how our body would, or our nerves, or how we would use the context or the connection between taking air in our body and then bringing it out in our lungs and then producing speech sounds while breathing out also. So these are all reflexes that are very easy for a human being, but are not possible for animals. Now, while animal communication does not seem to resemble human language, the question remains of whether animals are cognitively capable of acquiring language if they have human models. So, while animal communication, it doesn't resemble human language, but there is still a question. The question is whether animals are cognitively capable of acquiring language or learning a language if they have human models. Like, can human beings teach them to speak? Now, that I've seen only in parrots. A good example, the speaking parrots. बोलने वाले जो होते हैं मैंने सिर्फ ये example उनमें देखी है. They can repeat what humans say. Whatever, using a human model, a parrot, just that is one species that I am very sure that can repeat exactly what a human being is saying by repetition. Once again, the parrot cannot develop language or learn a language but by using his brain or his mind. But the parrot can learn few things by repetition. So वो अपने brain process को use नहीं कर रहा होता learn करने के लिए, लेकिन वो अपने repetition, imitation से वो सीख रहा है. So I think that is the only animal that I've seen. A number of researchers have attempted to teach chimpanzees or bonobos, pygmy chimpanzees and orangutans to express themselves using keyboards. So कुछ researchers ने जो है chimpanzees को सिखाना शुरू किया, but they can't make them make the speech sounds. They can teach them to produce those sounds through the keyboard. Despite strong claims about the cognitive and linguistic abilities of the animals studied, unresolved questions remain about the extent to which they use the keys symbolically rather than indexically, and the extent to which their productions manifest an awareness of word order and structure dependency. So sometimes it's not that clear. Now, the other factor would be anxiety. How does anxiety have a difference or an effect on language? Now, general anxiety is one of several affective factors which can influence attention and hence lead to a deterioration in language performance. So general anxiety would be one thing that would have several affective factors which can influence attention, and then it can lead to the deterioration in the performance of language. So, but there are also specific types of anxiety related to language which reflect the complexity or perceived importance of a language task and the extent to which the task places a premium on accuracy. So there are specific types of anxiety related to the language which would reflect on the complexity or perceived importance of a language task, and then to what extent do we take those places of accuracy. So an additional factor might be the individual's uncertainty about their ability to perform the task. If one person is individually uncertain that I am able to perform the task, that would be an additional factor. So this might result from introvert personality traits, people who are not used to socializing or communicating. Like if I'm a person who keeps to myself, I would be an introvert person who cannot speak his feelings out clearly to others. So that would be an introvert person. I myself am an extrovert. Okay, so it's very easy for me to communicate or socialize with people. So this might result from introvert personality traits if they are having difficulty performing a task, from a lack of self-confidence, or either it's lack of self-confidence or from awareness of limitations in a particular language skill. So there are two reasons why a person might say that his uncertainty would be that I can't perform this task. One thing, that he knows that he is not very good in the language. His skills are not very good in the language. So he doesn't have that much control over the language to use it. Or the other thing would be that he has the knowledge of the language, but he has very less self-confidence that he can use it. So those people mostly are introvert, and with them they would have difficulty trying to realize. So it could be either the lack of self-confidence or limitations of the knowledge of the language. So both factors can count. But for an extra person, it would be like somebody who can socialize easily. It's very easy for them to communicate. And generally they do tend to get self-confidence also. So an anxiety manifests itself in speech in a greater degree of pausing, in a lack of coherence, in the insertion of fillers such as you know, and in an increased number of false starts. So how does anxiety show? It would show in how you are pausing. If you're pausing too much during something, that means you're trying to retrieve the words. You don't have the knowledge, vocabulary knowledge of those words so clearly, but you're trying to retrieve them. So what you're doing is you're taking long pauses, or a lack of coherence, that something that you're saying but is not clear and not understandable. So that would also matter. Or an insertion of fillers that you're filling in, for example, like you know this, you know that, like that. Now these would be fillers. And in an increased number of false starts. So this suggests that the planning function is affected. Planning function of a human being is affected. So in the case of a foreign language learner, for example, when you're learning a foreign language, anxiety may sometimes lead to greater accuracy as heightened attention is paid to the form, but fluency may suffer as a consequence. So in learning a new language, what the thing would matter is that in case of when you're learning a foreign language or a second language, the anxiety may sometimes lead to greater accuracy. Sometimes you can be more accurate when you're feeling anxiety, as heightened attention is paid to the form, because you're paying more attention to the form of the language, but fluency might suffer. So you might be more accurate in a language, but you might not be that fluent in a language. So the consequences would be that you wouldn't be that fluent, but you would be more accurate, more precise, because you're putting more form on it. You're putting more stress on learning what the language is. So aphasia. Now once again, if we're talking about aphasia, a disorder in the ability to produce or to understand spoken language. Aphasia, like I said, is a brain disorder. So a disorder in the ability when we're trying to produce a language or trying to understand a spoken language, our disability to do that would be caused because of aphasia also, certain brain disease. So it usually results from brain damage caused by an accident, a stroke or invasive surgery, but some accounts include the effects of dementia. So dementia would be when you are getting older and you're forgetting things. So some effects could be from that. Some effects could be due to brain damage, either caused by an accident or a stroke, जैसे फॉलेज का आपको अटैक हो जाता है, or invasive surgery, or if you've had some sort of brain surgery, then that also would count on that. And some of it would include the effects of dementia also. So evidence from aphasic provides possible insights into the location of language in the brain. So evidence of aphasics, how do you see that this is aphasia? that it provides possible insights into the location of language in the brain, where language is located in the brain, and into the constituent parts of language processing, and from where your brain is processing the language. So some of which may be lost by an aphasic and others retained. Some things might be lost and others might be retained. However, it is dangerous to rely too heavily upon evidence from these atypical subjects. So we cannot assume that brain damage has wiped out a given aspect of language processing. We can't say that it has been affected completely by brain damage. So we can't say that it's completely wiped out, or nothing of that remains in it. So or that language processing has been damaged completely because of brain damage. So information may have been relocated. Maybe if one part of the brain is damaged, then our information has been relocated to another part of our brain. Or a process may be switched to new and less efficient channels than those normally employed. Or a process would be switched from one new to less efficient process of a channel than those that we would normally employ. So, well-established syndromes are associated with damage to the two language sensitive areas of the brain identified by Broca and Wernicke. So Broca and Wernicke identified that well-established syndromes are associated with damage to the two language sensitive areas of the brain. It is important to note that the characteristics of each type are merely possible symptoms. So sometimes we want to say that the characteristics of each type are merely possible symptoms of brain damage or aphasia. The exact effects vary considerably from patient to patient. So they are still different. So Broca's aphasia is often characterized by agrammatism, an absence of syntactic structure, and omission of function words and inflection. Or articulation may be poor and speech is generally effortful with many hesitations. So comprehension appears to be good, but it may be that the patient is using positional, semantic, or pragmatic cues to puzzle out meaning rather than relying upon syntax. So sometimes comprehension, understanding would be good, but sometimes the patient is using potential or positional, semantic, and pragmatic cues to try to puzzle out the meaning of certain things rather than relying completely on the syntax. So vocabulary is weighted towards, so comprehension, we would say that maybe understanding a language is easier than relying just on the structure of the language. So vocabulary is weighted towards concrete nouns with verbs sometimes underrepresented. So vocabulary is weighted towards concrete nouns. We can weigh towards that, but with verbs sometimes that are underrepresented. Now, Wernicke's aphasia is characterized by syntactically complex and well-structured speech, containing function words and correct affixation. So sometimes Wernicke's aphasia would characterize because we can't structure or the complex structure of a sentence or a word, or a well-structured speech, sometimes containing function words that are functional, and correct affixation of how to affix it. So speech is apparently effortless, fluent, and rapid. So most of the time the speech would be fluent and quick. Indeed, many of Wernicke's patients claim not to recognize that they have speech difficulties. So many of those people who are under this disease, Wernicke's aphasia, they might not even realize that they're having some difficulty in speech. But there may be severe problems in retrieving vocabulary. So what they're having is, they're not having difficulty in what do you call it, speaking or producing the speech, but they're having difficulty in retrieving, like I said, from your memory, from your permanent memory to the current, when you're trying to retrieve the vocabulary, sometimes they have to stop and think of what word to use where, with a reliance on general or inappropriate nouns and verbs, sometimes with grammatical structure also. So comprehension may be markedly impaired. It's maybe, you can visibly see that understanding is affected by it, or people trying to either explain things or trying to understand, both are impaired, both are damaged. So early accounts of Broca's aphasia associated it with impaired motor activity, which led to difficulty in assembling utterances. So early accounts of Broca's aphasia, that means they associated with impaired motor skills, like your motor skills, when they got damaged, then they said, okay, so that's related to Broca's aphasia, which led to difficulty in assembling utterances, when they had difficulty trying to assemble the words or the sounds into a sentence. While now in Wernicke's aphasia was said to reflect impaired access to stored lexical information. So in Broca's aphasia, they said it's difficult to assemble the utterances, while in Wernicke's aphasia, it was clear that said to reflect on the impaired access to the stored lexical information, whatever lexical information they had stored in their permanent memory. So maybe accessing that, retrieving that is difficult. So, however, Broca's aphasiacs show signs not just of being unable to use functors appropriately, but also of being unable to understand them. So in the people who are suffering from Broca's aphasiacs, they will not only show the signs of not understanding a particular sentence, but also in maybe not producing it, but also by understanding them, they're showing difficulty in it. Now the fact that the symptoms of aphasia vary, they're different considerably from patient to patient, suggests that the language sensitive areas of the brain may be differently located in different individuals. So sometimes when you see different symptoms of aphasia, different symptom in one patient and a different symptom in the other patient, then that sometimes does relate to or suggest that there is maybe the areas in the brain that are language sensitive, where the language is stored or where it's produced from, or which are related in your brain to language. Those parts are different, they're differently located in different people, different patients. So that's why their symptoms would be different. So alternatively, particular language functions may be so localized that a great deal depends upon the exact position of the lesion which inflicts the damage. So sometimes if your particular language functions may be localized, then you can say that a great deal depends upon the exact position of the lesion which inflicts the damage. So recent brain imaging data suggests a third possibility. The reason for the vulnerability of the Broca and Wernicke's areas is that they constitute a major crossroads for the neural connections, which transmit widely distributed linguistic information across the brain. So instead of relating type of aphasia to the area of the brain in which damage has occurred, clinicians prefer to analyze symptoms. A first observation might consider the extent to which lexical semantic processing is impaired, as against grammatical or sentence processing. So a first observation might say that instead of relating the type of aphasia that is relating it to the area of the brain in which it's situated, or where the damage has occurred, clinicians would prefer to analyze the symptoms more likely. So a first observation would be considered to be that the semantic processing is important. The processing of understanding the meaning is important, instead of as against to the grammatical or sentence processing. So maybe the grammatical and the sentence processing isn't damaged, but the first consideration or observation would be that the process of understanding the meaning is damaged. So however, a distinction is still often made between non-fluent aphasia of the Broca type and fluent or expressive aphasia of the Wernicke type. So, however, they would still consider this, that a distinction is still often made between the non-fluent aphasia, some people, the people who are suffering from aphasia but who are not fluent, or the Broca type and fluent or expressive aphasia of the Wernicke type. So maybe they are the Broca type and they're non-fluent, or they're the Wernicke type and are fluent and expressive. So other less discussed aphasias are, now those are the main things. The Broca type and the Wernicke type are the main things discussed. The other parts of aphasia that affect by this brain damage is jargon aphasia, conduction aphasia, transcortical aphasia, and anomia. So what does jargon aphasia mean? I did explain to you in the start of the lectures what jargon is. So jargon aphasia would be characterized by a large number of nonsense words in the patient's speech. So we can characterize it how? How can we judge that the patient is suffering from jargon aphasia? Because we can see that he's saying so many words that don't make sense in the patient's speech. If you can see that, that means he's suffering from jargon aphasia. Conduction aphasia. Now what does conduction aphasia show? Conduction aphasia characterized by an inability to repeat what has just been heard, though comprehension may remain unaffected. So characterized by an inability to repeat itself, so what has just been heard and what hasn't, though comprehension may remain unaffected, even though that comprehension would be unaffected. So transcortical aphasia, where the best preserved skill is the ability to repeat words and comprehension is often severely impaired. So sometimes in conduction aphasia we would say that the inability to repeat a word that has just been heard, that would be that, or trying to understand it. Transcortical aphasia, where the best preserved skill would be the ability to repeat the words, so it's easy for the patients to repeat the words, and comprehension is severely impaired. That means that they can repeat words easily, but they don't know the meaning of it. They cannot understand what they are saying. So that part is damaged in it. In anomia, now in anomia, where the main or only symptom is the inability to retrieve words. Anomia would be a part where they wouldn't be suffering from comprehension or repetition of words, but their only inability would be to retrieve words from their permanent memory, lexical items, things they can't think of words, so they would have difficulty producing language. Now features of these types of aphasia are observed to different degrees in different patients. So different patients have different degrees of aphasia, and you can judge it in different patients in different ways. So they suggest that the process of word form can be separated from the process of word meaning. So what we say is that they would suggest that sometimes we can separate it from the processing of the word from what the word exactly means. So now apraxia. What is apraxia? Apraxia is disruption of the ability to control the motor programming involved in an activity such as articulation of speech. So that would be a disruption in the ability that we cannot control. A patient cannot control the ability or the motor programming of the activity involved in the articulation of the speech. That means the way you pronounce the words. So argument structure would be that the syntactic pattern or patterns associated with a verb. The argument structures for give would be give NP1 and NP2, give Mary a present. And give NP2 to NP1, give a present to Mary. So the argument structure includes semantic information which specifies the appropriate thematic roles. So with give NP, noun phrase 1, has to be a beneficiary, and NP2 is usually a theme, an inanimate indirect object. So articulation. Now how does articulation matter? The physical production of the sounds of speech. How physically we produce the sounds of speech, and how that is related to the way the sounds come out, and they're produced for every alphabet, and the pronunciation of words. So fluent articulation is a highly complex motor skill involving the coordination of about 100 muscles at a speed that enables around 15 speech sounds to be produced every second. So what is fluent articulation? That it is a complex motor skill, and it involves about 100 muscles at a point, at a moment in the speed that enables us to we can produce then 15 different sounds at that point to be produced every second. Now the process is also highly automatic. We can only produce speech at this rate because we do not pay conscious attention to the process. So an articulatory gesture involves coordinated manipulation of the respiratory system, the larynx and the vocal tract. The first of these regulates the flow of air. The second, which includes the vocal cords, determines pitch and loudness and applies voicing where appropriate. So we can apply it where it's appropriate. Now the vocal tract serves as a resonator with changes in the oral, nasal and pharyngeal cavities. Now we've already studied about the cavities, so you should be very clear about what I am talking to you about right now. So you can refer back to one of your lectures. The vocal tract would serve as a resonator with changes in the oral, the nasal and the pharyngeal cavities, affecting the timbre of the sounds that are made. So the articulators within the oral part of the tract, the tongue, the jaw, the lips, the velum, serve to constrict or facilitate the airstream. I won't go in explaining that because we've already gone through that in a lengthy part of our previous lectures. So some commentators suggest that the smallest articulatory gesture takes the form not of a phone but of a syllable, with the adult speaker possessing a repertoire of gestures which cover all the syllables of their language. So the reason for favoring the syllable is that the articulation of any individual phoneme varies according to its place in the syllable and according to the phonemes which occur before and after it. A phenomenon known as co-articulation. Now, as part of planning for an utterance, the speaker thus has to weave phones into the phonetic context in which they will occur, and to predetermine the appropriate duration of each phone relative to the other. Now, in Levitz's model of speech production, articulation is the product of an articulatory or phonetic plan which anticipates the forthcoming chunk of speech. So what is it doing? It's like Levitz has produced a model of speech production, in that he's given that articulation is the product of an articulatory or phonetic plan which would anticipate whatever forthcoming chunk of speech is coming, what we are going to say. So the chunk covers one or more complete phonological phrases. So the chunk would do what? It would cover one or more of the complete phonological phrase. It is stored in a temporary buffer in the form of a program which specifies the neuromuscular operations that will be necessary to produce the desired sequence of sounds. Now, if articulatory system then translates the program into instructions to the muscles controlling the larynx, the articulators, and the respiratory system. So sometimes the articulatory system would then translate the program into instructions to the muscles. So our articulation system would work to give it as a signal to the muscles controlling the larynx. Like I told you, our larynx is right here. When we take in the breath, the way the breath comes out of our lungs, the larynx is a major factor where we can control what sounds we make. The articulators and the respiratory system, so how our breathing system works, how we can stop the air, and then suddenly the explosion of air, releasing it, could make a different sound. So a number of theories attempt to account for how we manage to produce speech sounds so consistently. So sometimes they have theories that would attempt to account for that, of how speech sounds are produced constantly, like we're constantly producing speech sounds. Location program account suggests that motor commands sent by the brain direct the articulators to a target position for each phoneme. So this explanation does not accord with evidence that the operation of the muscles involved in speech is highly coordinated and variable. Why? Because if any are obstructed to their movement, for example, if the speaker is chewing gum, let's say, others compensate to ensure that the articulatory goal is achieved. So even though if the speaker is chewing gum and not maybe pronouncing, there are so many other articulatory factors that would achieve the goal. Now, an auditory theory suggests that motor commands are coded in terms of phonetic features that the speaker knows as a listener. So in auditory theories, and that we suggest that the motor commands that are sent from our brain to our muscles or to our speech muscles also are coded in terms of phonetic features that are the speaker would know because he's also a listener. Now the view envisages a systematic relationship between the perception and production of speech. So just how we perceive the language and how we produce speech. So however it entails that the speaker has to wait for auditory feedback until he or she can decide if the articulatory target has been met or if an error of pronunciation has occurred. So there are two things. So even though it entails the speaker that he can wait for the feedback, but he or she can still decide that if the target was met or if there was a pronunciation error. A model referenced approach assumes that each speaker has an internal model of their own vocal apparatus. So a model referenced approach would assume that each speaker has an internal model, every person has their own model of their own vocal apparatus. Tactile and kinesthetic receptors in the vocal tract enable the speaker to build up a sensory image of the patterns in which the articulators are engaging. So sometimes they would build up a sensory image of how the articulators are engaging. Now, this image can be compared against the phonetic goal that the speaker aims to achieve. So, an even more rapid check-in mechanism is provided by a proprioceptive feedback in which part of the nerve impulse to the articulators loops back and is compared to the intended signal. So once again, it's impaired, and you can see that it loops back and is compared to the intended signal. A coordinative structure theory holds that articulation, in a coordinative structure theory, it holds that articulation is achieved by means of a string of tasks. So you can achieve articulation by different tasks or a line of tasks. Now, each task triggers a motor command to not one but a group of muscles which function temporarily as a single unit. So the attractiveness of the last theory is that it accounts for the way in which speech impinges upon other activities. So the coordination involved in articulation is highly complex. So not just because of the need to combine different articulators, but also because the vocal organs serve purposes other than speech. Now, the demands of speech have to be balanced against those of breathing by the respiratory system. Now, chewing and ingesting food by some articulators and protecting the air passages from intrusive food by the larynx. That's why they say that sometimes you shouldn't be speaking when you're eating. During speech, the speaker switches to a distinctive respiratory pattern or speech mode with greater air displacement and a more constant state of outflow of the air coming out, producing more sound and words. So similarly, although the same muscles are used in speech as in chewing and swallowing, they are coordinated in a different way, in a very different way. So articulatory settings, the positions adopted by the tongue, lip and palate, etc., vary from speaker to speaker. They do so partly because every individual has differently shaped articulators, vocal tract, tongue, mouth and dental structure. So setting also vary due to personal speaking styles. So also every person has their own style of speaking, so it does vary from that also. So articulation rate. Now the rate usually in syllables per second. How many words or how many syllables can we deliver per second, at which the actual sounds of speech are produced by a speaker, and how many actual sounds of speech are produced per second by a speaker. So an important distinction is made between speaking rate based on the overall length of an utterance, including pauses, and articulation rate based on the length of the utterance with pauses deducted. When speech is perceived as fast, the impression is often mainly due to a reduction in pausing. That is, speaking rate is significantly reduced, but articulation rate is not. So, articulation rate varies between speakers and between types of speech event. It also varies within the speech of an individual. When the same speaker repeats the same phrase several times, there are small changes in the relative duration of the syllables within the phrase. It appears that listeners are very sensitive to the articulation rate of speakers. So indeed, speed of articulation has been shown to be a factor in phoneme identification, enabling us to distinguish from ba from wa. However, because articulation rate is so variable, it is difficult to incorporate into theories of speech perception. For example, one way of dealing with the unreliability of the phoneme as a unit of perception is to suggest that listeners analyze the signal in slices of, say, 1/10 of a second. But the problem then is that any given slice of connected speech will contain different amounts of phonetic information according to how fast the speaker is articulating. So, but the problem would be that given a slice of connected speech, it would still contain different amounts of phonetic information according to how fast the speaker is articulating. So that would matter a lot also. Now, articulation rate varies from one language to another. How fluent you are in a language also matters. So reflecting the type of syllable structure that a given language contains. Now, languages also vary in how a fast speaker achieves an increase in speed of articulation. English speakers prefer to shorten unstressed syllables, to shorten vowels rather than consonants, and to reorganize syllable structure by means of elision, assimilation, etc. So sometimes they will shorten the vowels just to make the words shorter to deliver it in speed. So, articulatory suppression. Now, articulatory suppression would deal with an experimental task that interferes with the process of rehearsal in working memory. So, this is an experimental task that interferes with the process of how we are rehearsing in our working memory. So, it might require a subject to keep repeating a word such as the. So again and again and again, you keep on repeating, and maybe sometimes that does happen. Now, because this meaningless task involves speaking, it is said to prevent the subject from being able to rehearse or practice information subvocally. So it thus obstructs the learning of lists of words, which needs to be rehearsed in this way if they are to be stored effectively in long-term memory. Now, it also obstructs the processing of written material, since rehearsal enables us to recode such material into phonological form. So, artificial intelligence, psychologists and computer scientists have joined forces to create computer simulations of human cognitive processes. The processes studied in this way would include the understanding of language and nature, of expertise and how it is acquired, and how they acquire that language. So researchers working within A1 require a detailed information processing model before they can simulate an activity. Hence, the custom among psycholinguists of presenting theories is the form of models which resemble the step-by-step operations of a computer. So the argument is not that a computer would operate in the same way as the human mind, but that in designing a computer program, we can obtain insights into the real-life process. So sometimes A1 researchers and psycholinguists have different goals also. A distinction can be made between programs whose aim is to make computers intelligent, without regard to whether the process involved resemble those of human mind, and programs which attempt to shed light on human cognitive processes. So for example, computer programs designed to parse written text can achieve their goals on the basis of frequency, the statistical likelihood of a particular word occurring in a particular type of text, and transitional probability. So the statistical likelihood that word A will be followed by word B. Now, this ignores factors in natural comprehension, for example, word knowledge and the existence of a meaning representation of the whole text. So in the interest of efficient machine processing. So another difference between many A1 programs and natural language processing lies in the fact that linguistic information may have to be coded for presentation to a computer. So thus some A1 models of spoken word recognition, they depend upon the researchers describing or transcribing the utterance into phonemes. So sometimes they do have to transform it. So all A1 research explores a number of specific areas of human cognition which are relevant to language. Now there are so many numbers of things but these two would be like a number of human cognition areas that are relevant to language. One would be knowledge representation. So knowledge representation, knowledge systems simulate the form in which knowledge, including linguistic knowledge, is stored in the mind. How the system works and how we obtain knowledge and how we store that into our brains. Now in particular, the relationship between declarative knowledge, knowledge that, and procedural knowledge, knowledge how. So knowledge that we obtained and how we obtain. So learning would be another process. Learning systems simulate the way in which features of a first or second language might be acquired from the data that is available. So we can take features from different languages to see from whatever data is already available stored in our brains. The next would be inference. Inference, expert systems apply inference to a store of knowledge in an attempt to model the way in which the human mind analyzes data and arrives at conclusions. Now this may in time assist our understanding of how listeners and readers impose inferences upon discourse. The next thing that factor would be search. Now problem-solving systems attempt to trace the way in which thinking moves from an initial state to a goal state, choosing one or more paths and selecting sub-goals along the way. So here there are potential insights into, for example, the way in which speakers construct a syntactic pattern to express a preposition. A more applied area of A1 research aims to develop speech recognition programs. Now these projects face a major problem in the fact that human voices vary enormously in pitch. Everybody has a different way of pronouncing words, and a low or high pitch, in articulatory settings especially, in the size and shape of the articulators involved, and in the paralinguistic features such as braziness. So some programs, for example, phone answering systems, are designed to discriminate between a limited number of words uttered by a wide range of voices. So others, for example, transcription programs, are designed to discriminate between a large number of words uttered by one voice. So currently influential in A1 is a computational approach to lexical recognition known as connectionism or parallel distributed processing, PDP. It is based upon the transmission of activation between different levels of processing. So connectionist models often include a learning process back to propagation, which enables the computer to adjust its priorities in the light of successful or unsuccessful outcomes. So their proponents would argue that this can provide insights into the process of language acquisition, of how we acquire the language. So association now, associating something. An early experimental technique in psychology required subjects to look at or to hear a word, then to report the word or words which first came to mind. So the technique continues to provide evidence of how words are associated in the mind. Now subjects in word association tasks usually respond with a word that is connected to the stimulus by meaning rather than form. Words which rhyme with the stimulus, clang responses, are relatively rare. So this suggests that meaning associations in the lexicon are stronger than those of phonological or graphological similarities. So the meaning associations are usually based upon semantic groupings, not physical resemblance. Needless associates with thread rather than with the nail. So there is also a tendency to choose a word in the same word class as the stimulus. The three strongest types of association, by the way, would appear to be coordination, salt and pepper, collocation, butterfly and net, salt in water, and superordination, butterfly and insect. However, hyponyms, butterfly and moth, red and green, synonyms, hungry and starving, and opposites, hungry and thirsty, also feature. Now, further evidence for the strength of certain association comes from patients suffering from brain damage. So when reading a word, they may substitute and associate mauve for purple or sister for daughter. So that would also be an example. So attention one would be selective attention. We possess an ability to tune into certain sources of input and exclude others. There is a classic cocktail party effect where a listener can attend to a single person at a large party despite many others, often loud voices in the room. So yet when somebody, the other side of the room, mentions the listener's name, she is immediately aware of it. So it seems that we tune in to a particular speaker, but that we continue to monitor speech elsewhere at a low level of attention. So students, so that was about it for today's lecture, and we will continue the same subject and same topic in our coming lecture again. So thank you so much. Good day.